Hello guys, welcome to Civil Concept, and in this video I will show you how to calculate cement, sand and aggregate for M20 grade of concrete. Okay, so many friends were asking me about to tell the quantity calculation like cement, sand and aggregate for M20 and 15 etc. Okay, so I will show you here step by step process. So first of all we have to choose the mix ratio of concrete. Okay, either from which grade of concrete like M5, M7.5, M10, M15, M20 grade of concrete you want to calculate cement, sand and aggregate. Okay, so here first of all we have to choose the mix ratio of concrete. Let us take the mix ratio of M20 grade of concrete. Okay, I am assuming here M20 grade of concrete. You can take any of the above below. You can see here for M5 you have to take ratio 1:5:10. For M10 1:3:6, M15 1:2:4, and M20 and so on. Okay, so I am taking here M20, and you can see here in M20 we have to take cement, sand and aggregate ratio 1:1.5:3. So here you can see 1:1.5:3. So sum of the ratio will be how much? 1.1 plus 1.5 plus 1 plus 3 is equals to 5.5. Okay, so keep remember this sum of the ratio, that 5.5 it will be used in the formula. Okay, in next slide. Okay, so here I have taken out the sum of ratio is 5.5. Okay, it means that this let me describe something. M20 means what? M20 means this is the grade of concrete. Okay, this is the characteristic strength of concrete after 28 days, and this is the mix ratio. It means one part of cement. It means one part of cement needs 1.5 parts of sand and 3 parts of aggregate to prepare the concrete. Okay, so simply this is not difficult task, so you have to know this. So I have choose that mix ratio is M20, and the ratio is this much, 1:1:2, 1.5:3, and sum is 5.5. Okay, now we have to calculate the dry volume of concrete in step 2. Now we have to calculate dry volume from the concrete. For example, I am assuming 1 meter cube of concrete. Okay, it may be different according to your requirement. For example, 5 meter cube, 10 meter cube and 15 meter cube and so on. Okay, so here I have assumed 1 meter cube of concrete. We have to add 52 to 54% due to void and wastage in the concrete. Okay, so this is the shrinkage factor. When we add water in this either dry concrete, dry cement, sand, then it will shrink somewhat. So we have to increase the volume. For this we have to add 52% to 54%. Okay, so in 1 meter cube of concrete which we have assumed, we have to add 52%. Okay, so total volume will be how much? 1 plus 52 divided by 100 into 1, which is 52% of 1. Okay, so adding this we will get 1.52 meter cube. This is the dry volume. Okay guys, 1 meter cube we have calculated actual volume of the concrete. This is the wet volume, and we have to convert it into dry volume. To convert it into dry volume, we have to add 52 to 55%, but here I have taken 52%, and we will get 1.52 meter cube. Okay, in note I have written here, additional volume includes the volume of voids between the aggregate and loss of volume during the mixing. Okay, so I have already told you this is the shrinkage factor. Okay, so we have dry volume is this much. Okay, now we have to do what in step 3? Cement calculation. We will calculate cement from this 1 meter cube. Okay, so simply the formula is very simple. To calculate the cement quantity, we have to use formula cement part divided by sum of the ratio, which we have already calculated. I had told you in the first slide. Again I want to show you. Here you can see sum of the ratio is this 5.5. This is the sum of the ratio. Now here you can see sum of the ratio and dry volume, which we have already calculated. Okay, so this will be how much? 0.2736 meter cube. Calculation is given below. Here you can see 1. This is the part of cement, because we have already taken M20 grade of concrete. 1 part of cement, 1.5 part of sand and 3 part of aggregate. Okay, so here sum of ratio is 5.5 and dry volume is 1.52. When we calculate this, we will get 0.276 meter cube. Okay, this is the volume of cement, actual cement. And if we convert into bag of cement, then this volume should be converted into kg, and after that it should be divided into numbers 50 to get the number of bags, because one bag of cement contains how much? 50 kg of cement. Here I have written in this note, you can read here. So this is the volume. If we multiply it 1440, this is the density of cement. If we multiply it and divide by 50, then we will get 7.94 bags of cement. Okay, so here I have written 1 meter cube of cement is 1440 kg, one bag of cement is 50 kg. Okay, so to change bag, multiply by 1440 and divide by 50. Okay, I have clearly written here, you can read. Okay, so we have to add 7.95 bags of cement. Now in step number 4 we will calculate the sand quantity. Okay, similarly like cement, we have to calculate the sand quantity. So quantity of sand will be the same formula, part of sand, which we have taken how much? 1.5, and sum of the ratio we have calculated 5.5 into dry volume. So after putting all this value, we'll get how much? 0.414 meter cube. This is the volume of quantity of sand. Okay, so if you want to convert it into kg, then you can convert. Okay, if you don't, then it is not necessary, because it always come into meter cube. But when you are designing a concrete mix, then we have to convert it into kg. Okay, so convert this volume into weight, because convert this volume into weight, because 1 meter cube of sand is equal to how much? 1600 kg. So if we multiply it with 1600, we will get 662 kg. Okay, so this is the density of the sand, and it may be different according to the area, according to your place. Okay, so always convert the volume of weight for each during mixing. Okay, so this is only for design. If you want to convert, then you can convert like this, otherwise leave it. Okay, so this is the sand, and after that in step number 5 we will calculate the aggregate quantity. Similarly, we will use the formula part sand part. Here you have to write aggregate part. Okay, so aggregate part divided by sum of ratio into dry volume, and again if we put the value, you will get how much? 0.828 meter cube, and again its density is 1450, or it may be higher or lower. You can use according to your area and chart. Okay, so aggregate in kg will be, if you multiply it with density, we will get 1201 kg of aggregate. Okay, in summary, in step number 6 we will get how much? What will we do? We will calculate the water cement ratio. How much water will required for 1 meter cube of concrete. Okay, so the water cement ratio for M20 grade of concrete is generally 0.5. Okay, so if we go with this 0.5, then it means that 1 kg of cement will require 0.5 kg of water. Okay, so water required will be 0.5 into weight of cement, which we have already calculated, and if you multiply it with we will get how much? 198.5 liter of water. Okay, so in note, water content may be slightly different depending on the site condition and workability requirement. Okay, generally the water cement remains 0.4 to 0.7 or 6. Okay, so you can use according to your site condition and temperature. Okay guys, so in this way we can calculate the cement, sand and aggregate with water for M20 grade of concrete. Okay, so if you want to download this PDF, then you can visit this website, and also you can check this calculation with the help of website. For this you have to come at the website www.civilconcept.com. I will put the link in the description, and after visiting this website you will go on this interface 1 2 3 4 5 etc, and you can visit in number 7, concrete volume calculator. Okay, if you calculate if you click on this, then you will reach on this page, concrete volume calculator, concrete calculator to estimate concrete material. Okay, now you can calculate the volume of cement, sand and aggregate all together here, and just by clicking the dimension of the column, slab, beam etc. Okay, so here I am putting the length of concrete is 1 meter. Okay, meter. After that, width is also 1 meter, 1 meter, and the thickness also I am putting here 1 meter. Okay, because we have assumed how much, 1 meter cube of concrete. Okay, here we have assumed 1 meter cube of concrete. After that, what we have to do, we have to add the ratios of the mix. So we have added 1.5, 1.5 and 3. Okay, so number of concrete is 1 only. After that, number of tipper and tractor. If you are using tipper or tractor, you can put the volume of that, so that it will directly calculate the number of tipper and tractor, otherwise leave it. Okay, so dry volume into wet volume, I have taken how much, 52%. You can see here I have taken how much. To convert into dry volume, I have taken 52%. So I will put here 1.52 only. Okay, so now calculate here. If we click here calculate, it will give us in second all the answer. Here you can see wet volume of concrete required is 1 meter cube, dry volume is 1.52, which we have already calculated. Volume of sand, okay, volume of sand is this much, aggregate is this much, weight of cement is this much, number of bags of cement is 7.94, this much. Okay, tips of sand, etc, all. Okay, you can see the numerical below also. You can visit this website and calculate your result. Okay, so this was for today. Please like this video and subscribe this channel for new update about civil engineering.